to the new world. Guys, do you have any kind of idea about what is electric field? Before asking this question, I might ask you, what is a field? Is this some kind of playground? Okay, jokes apart. In this video, I would discuss about electric field from a whole new perspective. Enjoy. Hello guys, welcome to my channel Logical Electrical. My name is Saurav and today we will learn something new. Alright, in our last lecture we actually discussed about what is the main shortcomings of the Coulomb's law. Alright, and also we have discussed what is the definition of 1 Coulomb charge and how we can use the superposition principle in a group of charges. At the end of the last lecture, I have put forward a question to you that what is the basic reason behind this electrostatic force? Why the two particles are kept in vicinity, they will experience some kind of forces. So what is the origin of this electrostatic force? To understand that, we have to first understand what is an electric field is. Electric field, what is that? Electric field, before understanding electric field, first we have to understand what is a field. Generally, the crude definition of the field is basically, field is a region in space. A field is basically a three-dimensional region in space in which every point is affected or experienced by some kind of forces. Alright, I'm just writing down the definition. So what is a field? Okay. What is a field? So basically this is the complete definition of the what is a field. Field is basically a three-dimensional region in space in which every point is affected or experienced by some forces. Force. Okay. Sorry. So what does it mean? It means if there is any kind of region in space, it's a three-dimensional region, okay? Like so. It's a three-dimensional region. Okay, in this region, every point, the region is consists of an infinite number of points. Every point is actually affected by some kind of forces. So this is how. So this is actually called a field. Okay, now earlier we have actually discussed about the different kinds of fundamental properties of elementary particles. Okay, so these properties are basically, first is mass, second is a charge, and third is spin or magnetism. Okay, magnetism. So please write it down, the definition of the field. So these are the three fundamental properties of elementary particles. Okay. So the fields are basically generated due to these fundamental properties. You might be asking me how. Okay. I'm telling you how these three fundamental properties are actually create the field. It is the mother nature that usually done this thing. Okay, so due to the mass, the field is generated, which is known as gravitational field. So due to mass, the field is generated. Due to mass, the field is actually known as the gravitational field. Gravitational field. And due to the charge, the field is known as the electric field. and due to the spin or magnetism due to spin or magnetism, the field is known as the magnetic field. Okay, this is the three field. These fields are, so we can easily conclude that these fields are generated by due to this fundamental property of elementary particles, right? So this is the origin of the field. So now let us learn about what is an electric field. To be more specific, actually these fields are basically the consequences of these fundamental properties. All right. Now we will learn about what is an electric field. So what is an electric field? As we have discussed now, the electric field is actually due to the fundamental property of the charge. It is the consequences of the property charge. So electric field, I am just writing down the definition of electric field. Electric field is basically, it's a three-dimensional region in space around a static charge which can only be experienced by another charge. All right. So definition of electric field. Okay, this is the crude definition of the electric field. Electric field is basically three-dimensional region in space around a static charge which can only be experienced by some other charge. So it's a region in space, a three-dimensional region in space, assuming this is a three-dimensional region in space. Okay, this is a static charge. If you put a charged particle into this thing, then you would actually you will experience a force. Why? This force is basically the Coulombic force or the electrostatic force. I'm considering this is a plus Q charge, the stationary charge is plus Q, and if I put another plus Q charge, then it will repel, and if I put a minus charge, then it will attract. Okay, this is basically an electric field is. So this charge is basically known as the charge by which you can experience the electric field is basically known as the test charge. So this charge is known as the test charge. Test charge. And the charge due to which this electric field is actually generated is known as the source charge. So it is known as source charge. Yes, of course, this is also a charge. It will also produce an electric field, but it is depends upon our perspective. Okay, we are choosing this charge will actually create an electric field, of course. So that's why we are taking this charge as a source charge. If we just change our perspective and actually think about that it is our source charge, then it will produce an electric field and then it will become a test charge. But generally test charges are point charges. Okay, so this is known as the source charge. Okay, I think you have to understand what is a definition of electric field. Okay, in electric field, every point, as it is a field, so by definition of a field, we actually like to think about that, and that every point is actually affecting some kind of forces. We'll experience some kind of forces. So in every point, these are actually experiencing some kind of forces. Okay, in every point. That is basically the definition of electric field is. So I think we actually get our answer. What is the origin of this electric field? Okay, let me clarify something. Let me clarify this. So what happened? It is an electric field. Okay, this is my source charge, and okay, this is my source charge, and it is a three-dimensional field. Okay. Now, according to the definition of electric field, every point is actually affecting by some kind of forces. Okay, this point is affecting by force, this point is also affecting by force, like and so. Okay. So, if you put another charge into that, or into any point into that electric field, it means that you are putting a test charge into any point in electric field, so that point also will actually experience some kind of forces. Yes, according to the definition of electric field. So this force is basically known as, so this field force, inside the field, the force experienced by this charge, this field force is basically the electrostatic force. Okay, so that is basically the origin of electrostatic force. So this field force, this electrostatic force, which is actually introduced by us by the Coulomb. Okay, so I think we have get the answer. So the next question is, as we have actually understand that in every point in the electric field, there is it will experience some kind of forces. So as we know, force is a vector quantity, so every point magnitude and direction is changes in every point. So in every point in the field, there's a different values of forces are actually there. So we can easily conclude that in every point that there are different values of forces will act. So my question is, how can we determine in which point we will feel less force and which point we will feel more force? Are you getting me? Which point I will experience more force and which point I will experience in less force inside an electric field? How can I determine that? We can easily determine that by introducing a new physical quantity, which is basically known as the electric field strength, or in other words, electric field intensity. Okay, so what is the electric field strength or electric field intensity? So electric field intensity. The electric field strength or electric field intensity is basically defined as, or in other words, electric field strength or electric field intensity at any particular point is defined as the total amount of force experienced by a unit positive charge when it is placed into that particular point. Okay, so time for the definition. Okay, electric field intensity is definition. So this is the complete definition of the electric field intensity. Electric field intensity at any particular point is defined as the electric field intensity at any particular point in an electric field is defined as, okay, this is the complete definition of the electric field intensity. The electric field intensity at any particular point in an electric field is defined as the force experienced by a unit positive charge. So what does that mean? It means that if this is my electric field, let's assuming this is my source charge, and if I put a test charge of the value of Q in a point P, this is the point P, then it will experience force. That force is actually the electrostatic force. So electric field intensity is actually written as this. Electric field intensity is actually defined as the force experienced by per unit charge. It is a vector quantity. So as the force is a vector quantity, so electric field intensity is also vector quantity. Inside a field, every point having the different values of forces. So that's why in any point in the electric field intensity is different. Okay, so this is the general mathematical expression. Okay, so electric field is always, you have to, when you are giving the definition, you have to always mention the particular point. Okay, so here the point is actually P. So let us do some mathematics on this. Okay, I think you have written down this. Okay, so we have the electric field is equals to force per unit charge. Okay, this charge is placed in that particular location. I'm not actually using that point, okay, right now in the expression, mathematical expression. So what is the value of this force? According to Mr. Coulomb, this is the source charge and I am putting the charge at P, okay. This is the Q charge. This is plus Q charge. This is also plus Q. So what is the force? So force is equals to 1 by 4 pi epsilon 0 times that is Q divided by R square. This is basically the distance of R, let's say. Okay. So I'm assuming these charged particles are actually this electric field in the vacuum or air medium. Okay. So the value of the forces I am written down here, the 1 by 4 pi epsilon 0 times Q divided by R square divided by Q. So you can easily that this Q and this Q is actually cancelled out. So what is actually remaining here? That is 4 pi epsilon 0 times Q divided by R square. So this is basically the expression for the electric field. Okay. To be more generalized, that is Q by 4 pi epsilon 0 times R square. Okay. This is basically the generalized form of the electric field intensity, magnitude of the electric field intensity. You can easily see the electric field intensity magnitude is actually fall over R square law, all over R square. So the range of the electric field by the mathematics is actually in the infinite range. So if you put a charge in a very far from the source charge, then by this expression we can see electric field intensity falls over R square. So if you put a charge in very far, so electric field intensity will be almost zero. So I think this is all for today. In the next lecture I will actually discuss about some different kind of thing. Okay, I am just giving you the question. Think about it. To understand the behavior of the electric field under different circumstances, we have to visualize that. Now how we can just visualize the electric field? Okay, it's quite invisible to us. So how can we visualize that? So this we will learn in the next lecture. Okay, till then, if this video is very much helpful for you, then please subscribe to my channel. Bye. Thank you.
Think basic, think logical.